Hey everyone, I'm Jack Hamburger. I'm a software engineer in New York City at Applied Predictive Technologies. This is my coworker, Louis Antonelli. He's also a software engineer with us. We're here today to talk about quantifying React best practices. We've heard a lot at this conference about server-side rendering and optimizing page load times. We're going to talk about what happens on the client. So why? It's 2017. Everyone expects immediately responsive web applications. When the user interacts with a page, the response should be imperceivably fast. In React, excessive rendering is the cause of a lot of performance issues, so you have to be aware. React fundamentals will supersede any Babel optimization flags and low-level JavaScript optimizations. A component that doesn't render unnecessarily is always going to be faster than a component that over-renders in an optimized manner. So the best practices we're going to focus on today are pure versus functional components and the key prop with arrays. So this error message, I think pretty much everyone who started to work with React has seen this. It says that each child in an array should have a unique key prop. So the first time you see it, you probably react like this. You're not really sure what the key does. You just add it anyways, move on, and you just know it affects performance. We're just going to dive a little bit deeper into what that means.
Cool. So to illustrate our point, we're going to take a look at two very common user interactions that occur in web apps and native apps nowadays. And we're going to illustrate for each example the difference between performance and functional and pure. And we've averaged over 5,000 iterations with a component render time of 10 milliseconds to represent any work that needs to be done in your component. In the functional case, we have a name prop that comes in and returns a div. And in the pure component case, it's the same exact render function, but it's using React's pure component class to represent a properly implemented should component update in your components. Quick legend, anytime you see red, it means a re-render occurred, and if you see red in the middle for that arrow, it means the props were unequal from the current props to the next props. So the first common interaction for a user is to actually prepend to an array or unshift. And this occurs in tweets, blog posts, pretty much any complex outputs that you see. And the use case we looked at here was actually 5 of those components on a screen, so like in the visible window. And we'll see the user adds a component, and we see in the first case we have the original 5 nodes reconciled properly there and only incur 10 milliseconds for that new component at the top. And of interest here is the new component in the unkeyed example actually appears at the bottom, and then 5 re-renders occur due to the prop change in this case. So we actually see an NX increase in speed or performance degradation. For the functional case, same exact setup. And we'll see in both cases, even with the key in the functional case, we're actually incurring that 60 milliseconds in both cases. Even with the same reconciliation, we actually incur those re-renders due to the nature of functional components. So the important takeaway here is that in the unkeyed pure example, we actually see just as poor performance as the keyed functional. Jack will take a look at another very common interaction.
All right. So now we're going to look at swapping elements in an array. This is another common interaction you'll see with array mutations in web applications. Again, we'll start with the pure components with the key on the left and the unkeyed on the right. So we'll swap the second and fourth elements here. So we see in our keyed example, we reconcile correctly. Due to pure components having consistent props before and after, we won't re-render anything, and the cost incurred is just during the reconciliation process. In the unkeyed example, we'll see that we correctly reconcile 3 out of the 5 components and incorrectly reconcile the second and fourth. This is due to React, in the absence of a key prop, is going to naively reconcile based on index in the array. So we'll see the first, third, and fifth components are reconciled correctly, the props don't change, no re-renders, and we'll re-render those 2 that have the changing props. Again, we'll move on to a functional component example. And we'll do the same mutation of swapping the second and fourth elements. So as you can expect, we re-render all elements in the array in both cases. The props don't change in the keyed example, but we still need to re-render because there's no should component update check. In the unkeyed example, we'll see a similar reason for those 3 that do reconcile correctly for their re-rendering. So a big takeaway here is you'll get that red error message that we showed earlier when you don't use a key. But actually, if you used no key with pure components, you're going to outperform functional components with keys. So you'll get a red error message for one and not the other. So the takeaways here, you need to be aware of when your components are rendering. be aware of the implementation of should component update, whether it's explicit or implicit. In React, we like to talk about how UI is a function of state, but we also have to be thinking about how a performant UI is a function of state and next state.
We'd like to thank the organizers and everyone. If you want to talk to us after this, you can find us in the lunch line. Thank you.